Right, good evening everyone. It's nice to see so many people here tonight. Welcome to Beacon Astronomy Group. I'm Tim. For those of you who have come from Ramsgate or any other new people, we try to hold these events at least once a month, about once a month on the first Saturday-ish of the month. It's a bit odd this time round. I think this is the second Saturday, isn't it? I've lost count, but normally it's the first Saturday, and we try to have a general interest talk that will be interesting for everyone, and this time's no exception. We've got with us tonight, as many of you will know, John Hislop. John and I ran the Moncton Stargazers together for a little while, so we know each other quite well, and before we went our separate ways, and I started up the group here and John started up the group in Ramsgate, which you guys will know. And John's group runs, it's a very practical group, isn't it? Very with telescopes and observing. And he runs impromptu sessions when the weather's clear, which is great because trying to do astronomy on a schedule really doesn't work very well because it's cloudy all the time and you can't predict the weather. So if any of you do want to get out with a telescope and you haven't been able to, join his group and you'll get to observe with better probability. So, John, you've been a lecturer with Open University, haven't you?
Yeah.
And before that, it's all a bit murky. So, with that, without any more ado, I'll hand you over to John, and you're going to take us on a journey through space and time.
Yeah, I'm a retired physics teacher and a STEM ambassador, which means I do outreach in schools, whatever. In fact, this afternoon I had a session with my youngsters and we've got two of them here. Where are they? Right, so we do all sorts of electronics, coding, that kind of thing. Okay, so as Tim said, we used to work together at Moncton Nature Reserve, fabulous observatory, and we spent many happy evenings there. We would get about 20 people or so, but no more. No, sad face, yes. They took the telescope away. Yeah, lovely telescope. Tracking, you didn't have to keep on getting it back together, you know. So it was really good. But I've not been back since, so I don't know what's happened to it. Because now we're at Ramsgate seafront. That's the boating port and it's much better. I don't have to clean the tyres of chalk anymore when I get home. There's a bar nearby and parking is very simple. So they did us a favour by scrapping Moncton. Yeah. So this is my telescope. It's a basic refractor, does the job. Yeah. And we've had a few turn up in the evenings. There's Tommy at the far left there with his tracking telescope. Hey. Zach is in the audience there with his homemade 3D printed telescope. Wow, that's right, yeah. Yeah. And best thing about it is for the children, it's low down. They just... And Abby, who was also in the audience, she got that at Christmas and she brings it along to sessions. Right, so as Tim said, when do you have a session? When it's clear. When is it clear? Hardly ever. I look on the weather websites. Oh, there's a moon symbol. Right. That's about 5 days beforehand. As you get closer and closer, it turns to rain. It was so bad on the Met Office. They said it was cloudy, 100% cloud. It was glorious sunshine outside. So I wrote to them. I said, "You got it completely wrong." What did they say? Oh, blame the computer. Nothing. So I use The BBC website now, they have a different supplier of the forecasts, and they seem to be a bit more reliable. In fact, they're predicting next weekend should be clear. Should be, maybe. We'll see near the time. So, right. As you saw there, my telescope is very basic. I don't have a tracking telescope, all that fancy stuff. But what do I do to prepare for an evening viewing? Do you have your almanac? Only £4 from the works? Yep, nodding, yes, yeah, well done. This is a really good book, probably out of print now, but it tells you about what you can see in the night sky by seasons, rather than by constellations, which is much better, right? And finally, which for serious astronomers, deep sky objects. You do need tracking telescopes, cameras, what have you, for the deep sky, right? Okay, I belong to the Society for Popular Astronomy. It's a good society. You get a magazine and it tells you what's on each month. And JPL is a really good source of information. At the beginning of each month they produce a little video, and this one for February is worth watching. They combine the fact that we see Venus in the night sky now with Valentine's Day coming up. Oh, right. Worth a watch. Right, so what we're going to do this evening is go on a journey through time and space, travelling as if we were on a light beam, travelling at the speed of light, which is what? 300. Oh, you know exactly, do you? Well done, Abby. Made you learn the exact number. Can we use 300,000 kilometres in a second? Yeah. You can't go at 300 kilometres per thousand because it's faster than the speed of light. Yeah. But don't, yeah. Right. So off we go. What's the first thing we'll meet? Almost straight away. No. Meteors in the mesosphere. How high is the mesosphere? Right, I'm looking at Abby all the time because she's doing GCSE science and she knows all the answers. Putting her on the spot all the time. 70 kilometres, yeah, that's right. Right, mesosphere. So we might pass a comet, a meteor on the way. Right, only 300 microseconds from starting our journey. Almost straight away then, yeah? Are there any around at the moment? Have you seen a meteor? Shooting star, yeah? Did you make a wish? Yeah, of course you did, yeah. Coming up in April, we have the Lyrids. Okay, we just missed the Quadrantids, yeah? So, where do you look? Well, near Lyra. Okay, in April, rising in the east. Okay. What's the downside? You have to, this is 12:30 in the morning, yeah. I remember the Perseids. Do you remember that evening, Tim? Lovely warm evening at Moncton. We had about 100 people turn up, all laying back on the grass, looking up at the night sky. Oh, there's one! There's one! Yeah, you remember that, so. A millisecond away, 400 kilometres up in space. Where are we now? We're passing a space station. And I'm sure everyone in this room has seen the space station go over. Yeah. If not, go to Spot the Station website. So, on the 19th, 6 o'clock in the morning, no, wait till the 18th of March, yeah, and more sensible time. Yeah. So, poor Sunita, yeah, should have come back down, but she's stuck up there with, what, 6 other men? Poor thing. Right, but she's having fun up there, doing spacewalks and speaking to children down on Earth. Right, schools can speak to astronauts. Is there anyone in this room who's spoken to an astronaut up in the space station? Oh, Audrey, you spoke to an astronaut while they're up in space. Who was that then? Jasmine Mogbelli. Oh, well done, Audrey. This is her school, St. Peter's School in Broadstairs. So we had a massive antenna, Yagi, yeah, to track the space station as it went across. They only had 10 minutes to ask their questions, because then it was gone. And this is Isabella speaking to Jasmine. Yeah, so that's thanks to amateur radio on the International Space Station, ARIS. Okay, that was my amateur radio club has organised 2 of these kind of contacts. One at Wellesley House in Broadstairs and St. Peter's. We hope to plan another one. Can't say anything at the moment, it's all confidential. But yes, we hope to do another one. So, what would you ask an astronaut? The children submit their questions and we choose the best ones. Crossing out, how do you go to the toilet? We don't want that one. We all know that one. So what would you ask an astronaut? Anyone got a question? Oh, Tim, yeah.
I was asking what science projects are they working on.
All right, yes. Yeah, because they're doing lots of experiments up there. Yeah, lots of science. Oh, yes, good.
How zero G affects the body, because in zero G, blood can rush to your head, and astronauts look like they have puffy heads because of zero G.
Yeah. Yes. You'd like to experience weightlessness yourself?
Yes.
Yeah. Go on one of those comet planes. Yeah. Right. Carrying on our journey, 1 second away. Where are we now? The moon. Yep. We've reached the moon. Okay, this is taken by one of our Ramsgate stargazers in Hampton. And it's taken by Zach on his phone. Right, come on in. Do you want to say anything, Zach, about that? No? Was it easy to do?
No, it
It's
was difficult.
yes, it's not easy on the phone, is it? Yeah.
Sorry, is that taken through a telescope?
Yeah.
Stupid question.
Yeah.
Another one. Oh, right, tonight, yes. Did you see the moon before you came in? Yeah. So at the moment, it's near Mars and Jupiter. And it's only 11 days old, meaning, what? What's it doing then? It's waxing then, isn't it? Yeah. Yeah. Right. Back to amateur radio. They actually send signals to the moon, reflect them, and they come back to Earth and they can speak to somebody else on the planet Earth. Amateur radio people are a bit crazy, aren't they? Right. The sun. Yeah, we've reached the sun. Yeah. And the sun has these kind of blemishes, cooler areas on its surface, sunspots. And at the moment, the sun is very active. It has a cycle of 11 years. And at the moment, it's nearing the peak. Okay, so 169 sunspots. So again, at St. Peter's School, that's Ramsgate stargazer Tommy with his solar telescope. Do we have many solar astronomers in the room? Solar, yeah. Solar telescope, yeah. Excellent, yeah. So children are safely looking at the sun. Mm. No, amateur radio again. Why is an active sun good for amateur radio? Anyone know? Audrey.
Because it can help, because the sun is so active, it can give more energy, so it'll be easier for the amateur radio.
More energy. Abby, what's she trying to say?
She's trying to say that the radiation from the sun, so the ionosphere, it has obviously a bunch of ions in it, but it's very it's got lots of active electrons in it, and when the sun's more active, the ionosphere is more active.
Yeah, exactly.
It makes it a lot easier for the signal.
Yes, well the radio waves go up to the ionosphere, come back down again, and you get good propagation. When the sun's active, the particles interact with our atmosphere and you get the northern lights. Back in May, taken by Paul Crow. Anyone else got pictures on their phone? Yes, yeah, everyone's nodding. Yeah. No, you missed it?
Yeah, I went out to look, but
No, with the eye it's not so good. You need the camera to get the picture, which is not quite the same thing. Did you not see a tinge or something?
I think I did. But
Yeah, same here, yeah.
I've seen it in Scotland, in the Highlands, where it was actually quite good. I could see it quite easily.
Where was this?
Oh gosh, the Highlands.
Oh, the Highlands, oh yes, yeah. Up north, yep, definitely. You were lucky, yep. But it came right down to Kent, didn't it? Yeah. So, yeah. Probes have gone very close to the sun. The Solar Parker probe got extremely close, temperatures reaching 1,000 degrees Celsius on the probe. Yeah, so we're still finding out about our star. But the moon will eclipse it slightly. There'll be a partial solar eclipse, in March, end of March, on a Saturday in the daytime. And you need the glasses. If it's clear, we'll be there on the Ramsgate seafront, and I'll have plenty of glasses for you to borrow. Okay, so put that in your diary. I think it's 29th of March. Yeah. Okay, so Tim, you can apply for them as well. Yeah. Right. Past the sun, we're visiting the planets now, and everyone's heard of this, haven't they? The Parade of the Planets happening. Yeah, it's on the news. Yeah, news feature. Get out there and look at the planets all in a line. This is a poster from the Greenwich Observatory, £23. They've got an exhibition of astrophotography there, which apparently is very good. So half term, take a trip up to London, to Greenwich, and have a look at these photographs. Yeah, okay. Now, I watched that JPL video, and it said because when the planets come together, it's not a conjunction, but a pulse. Have you come across that? No, even Dirk's shaking his head. What's a pulse? Yeah, it's new to me as well. So have a look at that video. They reckon the proper term is a pulse, not conjunction. There you go. So where can you see the planets? This is 8th of February tonight, 6 o'clock. A lovely clear sky. So Saturn, we saw Saturn through our telescopes, we saw the rings, yeah, near Venus. Looking south, yeah, we've got Jupiter high up, this is tonight, and Sirius, follow it up to Jupiter. And then in the, Uranus is there as well, But you need a telescope to see it. Yeah, you need to know where it is. Right, so that was up there. This was taken by Paul Crowe again with his Celestron. With his fancy filters, so serious astronomer. And that's what you get to see when you look at Uranus. We saw it, didn't we, Tim, at Moncton? Yeah, we can say we've seen all 8 planets, thanks to the telescope there. Yeah. Neptune, between Venus and Saturn. Again, you need a good telescope to find that. Human eye, no. Poor old Mercury. Right, it's there because that's Neptune and that's Mercury. Very difficult to see. It's low down near the horizon, near the sunset. Right, that's a challenge for you. Yes. Have you seen Mercury yet? No. Coming up, if it's a clear night, maybe next week we'll be able to see it. Right, Paul again. Yeah, it's a good photo of Mars. Not very red looking though. All his filters are changing the colour. Right, so back in January it was quite bright, but it's getting dimmer now. It's getting further away from us. Yeah, so AU, astronomical units, is one astronomical unit is our distance from the Sun. And a bit confusing, these numbers, minus 1.3, minus 0.8. So the bigger the number, the brighter it is. A bit confusing, so it's getting dimmer. Right, Tommy, taking a fabulous picture. He's got one of his moons in there, and the bands. We think we can see the bands through our telescopes at Ramsgate. Is that right? Yeah, yeah. But Tommy's got proper tracking telescopes and everything, so fair enough, yeah. Right. So, how many Jupiter years old are you? Jupiter orbited the Sun how many times? If it takes 11 years for each orbit, I'm a little bit over 6 Jupiter years old, maybe a bit more. Right. So, Audrey, Jupiter hasn't orbited the Sun yet, has it, in your lifetime? No, she's not 11 yet. Are you 11? No, no. All right. The rings of Saturn, a must-see. Yeah, you can see them at Ramsgate. Yeah, so this was taken by Tommy. Right, this is the distances from the Sun in astronomical units. So Earth is 1. So if anyone says, how far is the Sun from Earth? 1. Yeah, 1 astronomical unit. Or if you prefer, just over 8 minutes. But there you can see that Jupiter is 5 times the distance that we are. Saturn about 10 times, twice as far again. Uranus 20 and Neptune 30. We can't see Uranus and Neptune, too far away. But it also brings in the point, if that's for light travelling, it's the same thing for radio waves. So when they land on Mars, right, when I arrived here, I had to send a radio message to my wife, arrive safely, right? So the astronauts, when they get to Mars, they'll send a message back to Houston, arrive safely. How long will it take for the message to reach Houston? Well, it depends where Mars is in relation to Earth. It could be as much as 20 minutes. Anything between about 3 and 20 minutes. Not good for conversations. But it's also not good for guiding rovers. Right? The rover has got a camera on it. There's a rock in the way. You've got to get out of the way. So they've got to see this ahead, and bear in mind it could take 15 minutes for the signal to get to the robot to make it change direction. Yeah. Right, this gives us some idea of the scale of the planets. Right, yeah, we're down there somewhere. 4 rocky planets and the 4 gas giants. Well, certainly Jupiter, you can fit 1,000 Earths into Jupiter. Pluto, not a planet. No. But then compare that to the Sun. Right, yes, we're a tiny planet orbiting the Sun. It's huge, yeah. It's up there somewhere, despite the cold, yeah. Okay. So, which star will you see in the night sky first of all? Which will be the first? Twinkling away. Sirius, yeah, brightest star in the northern hemisphere. Yeah, only 8.6 light years away. Yeah, but why is it twinkling? Oh, somebody at the back there?
Fluctuations in the radiation coming out.
Well, why is it fluctuating then? Yeah?
Yeah.
The atmosphere, yes. The light has to go through the atmosphere, gets disturbed, and makes it look as if it's scintillating or twinkling. Yep.
Is it, I'm pretty sure that Sirius is a binder between the A-type star and the...
There is another one there. Yes,
towards CSB.
you're quite right. Yes, there is another one there. Yeah. Right, there's some interesting constellations visible in the night sky now. Setting in the west, Pegasus and Andromeda. Obviously Orion is the star of the show, looking south, and Taurus, the bull. Coming up in the east is Leo, the twins, Gemini, you can see in the evening sky. And the north, Cassiopeia is up high, and Ursa Major and Cepheus. So these are the constellations. Yeah, Orion. So Jupiter up in Taurus. You've got a star there, Aldebaran, red star, which is not in Taurus apparently. Yeah. Lots of other constellations which are difficult to make out. Lepus the rabbit, yeah. Cetus the sea monster. But yeah, setting in the west, square of Pegasus and Venus there. And what have we got here? Yeah. Right, where are we now? This is rising in the east. Ah, there it is. Leo the lion. Yeah. Okay. Looking north, so Cassiopeia is high up and Ursa Major low down. Now there's a star here, this one, right? Looks like a house, doesn't it? Cepheus. So just on the left of the house, that one is Cepheus Delta, and it's an important one. Right. Shapes, asterisms, right? The W shape, or when it goes round, it's an M shape. Big Dipper, Plough, Saucepan. The Winter Triangle. Which one's that? It's a new one. Right. 3 stars making a nice isosceles triangle. Right. Betelgeuse, Sirius, and Procyon. Yeah. As opposed to the summer triangle. Vega and Aquila and Deneb. Lots of interesting stars out there. Stars, as you were saying, like Sirius, double stars. Stars that vary in brightness, star clusters, little galaxies and nebulae. So what have we got? Betelgeuse is interesting. We saw Betelgeuse earlier on, huge. So let me just check. Yeah, so Betelgeuse is huge compared to the Sun, which is 1 pixel down there. Yeah, so we are now 650 light years away from Earth. Boom, it's exploded. I reckon this very minute. What? It could be. It could be a supernova as we speak, but we won't find out for another 650 years.
For stars to explode, it takes time, but also you can't really predict when a star is going to explode.
We're there.
It's probably a 10,000 year range.
It's a red supergiant. We've arrived at Betelgeuse. It's going to explode. I'm telling you. It will, yeah. Right. It's not the biggest. Antares, even bigger. Aldebaran in Taurus. Yeah. So, yeah. Okay. It's a test of your eyesight. In the Big Dipper, there's a double star, 2 stars together, orbiting each other, 2 suns in the night sky. And Mizar is itself 4-star system. Can you imagine what that's like? Yeah, so that's clearly visible all throughout the year in the northern skies. Now, go back to Cepheus again. It varies in brightness, and it only takes 5 days to change in brightness. Okay, so you find it, say, right, it's as bright as that star over there, which doesn't change in brightness. Make a note of it, it's the same brightness as whatever, and you can look up the brightness of that. Next day, oh, it's not as bright as that star, it's bright as this one now. It's getting brighter. Right? So you note every night its brightness compared to other stars, or you take a photograph and you find its brightness changes over a 5-day period. I did have a go at this at Moncton, and Tim's nodding. Yeah, but we were thwarted a bit by the weather, weren't we? Yeah, I think we got 2 or 3 nights and we could see it changing in brightness. Yeah. Why is this important? Because an astronomer, Henrietta Leavitt, realised that these kind of stars are in other galaxies. So the Andromeda galaxy had stars like this, and you can tell from the period, 5 days in the case of this star, how bright it is. Right? The brightness depends on the period of change. So if you know the brightness, you can work out the distance. So all the distant galaxies that Hubble looked at, there were these kind of stars in the galaxy. So you pick out that star, find out its period of luminosity, how long it takes. You can work out then its brightness, but it's going to be very dim because it's a long way off. But you can work out that distance from its brightness. So Hubble was able to work out the distances of these distant galaxies thanks to Henrietta's relationship, right? So he got the distances and he knew how fast the galaxies were moving away from us, from the change in the colour. When red, for example, red moves away from you, it changes to infrared. Right? The light will change colour. That's why we have a James Webb telescope which has all these mirrors and it looks at the infrared. We don't look at the visible because there is no visible. The galaxies are going away from us and the colour changes. Okay, so Hubble, as you know then, figured out the expansion of the universe thanks to this kind of star changing in brightness. Okay, all the galaxies are moving away from us except for one. Right, there are lovely star clusters, groups of mini galaxies if you like, 7 sisters, Pleiades, or Subaru, as the Japanese prefer. All right, good test of your eyesight. Through a telescope, they look like diamonds in the sky. Beautiful sight. Okay, so they're up there now. You just see a sort of hazy patch, right? Look through binoculars or a telescope. The Hyades cluster is up there as well. That's Aldebaran in Taurus. And I had to put this one in, right? That's visible in the night sky. You won't see the nice green through a telescope. That's obviously taken with a tracking telescope and a camera. But yeah. Nebulae, sort of vague regions in the sky. The M42 nebula is in Orion, in the sword part, and you can see it through the telescope. All you see is just a smudge, nothing exciting, nothing like that. Right. But that's where stars are being born. It's a stellar nursery. So, visible tonight. The Crab Nebula is one to look out for. Again, you just see smudge, but what you're looking at is the leftover remnant of a supernova. Back in 1054, a star exploded. It was visible in the daytime, right? Yeah, Chinese astronomers put it in their notes. Yeah, and that's what we see now. Crab Nebula. So you can see stars being born, you can see where a star has died. This has been in the news, hasn't it, recently? The Blaze star, supposed to change in brightness every 80 years. Hasn't changed yet, as far as I know. So, but full marks to the person who spotted it 80 years ago. He was in the news, wasn't he? And he saw that there was something in the sky there which shouldn't be there. It was brighter. And so now we're looking out for this change in brightness, which could happen any day now. Okay. All right, there are galaxies on show. Obviously the Milky Way. Yeah, you can see that down at Ramsgate. It's dark enough to see the Milky Way. This is taken by Rob Knight. Right, Romney Marsh, yeah. It's an incredible photo. Yeah. It's got the dark bit in the centre. Yeah. The Andromeda Galaxy. This is going to be our challenge down at Ramsgate. See if we can see it. We definitely saw it at Moncton. Fabulous sight through a telescope. And that is very big. It's about a moon diameter through the telescope. It's big. But it's coming towards us.
You see it quite well with binoculars.
Yes, look through binoculars, yeah. Okay, this is the gravitational forces between our galaxy and Andromeda are bringing them together. So where is it? Right, well you find the square of Pegasus and you count from that corner to 3, 1, 2, 3, and then 90 degrees, 1, 2, 3, there's your Andromeda Galaxy. Okay, so give it a try. Yeah, we shall certainly try next week. Right, this is where the serious stuff comes in then. Even deeper, further back in time, distant galaxies. Right. Right, that's visible in the night sky now. Similar to our galaxy. Yeah. Beautiful, isn't it? Yeah. And visible all times of the year in the Ursa Major. M81, 82. Right. And there are lots of galaxies out there which you can see with proper tracking telescopes. These are just some of them to look up when you get home. There's our local region of galaxies, right? The realm of galaxies is visible now, and you can go galaxy hunting, right? But you're looking way 60 million light years away, back in time. Thousands of galaxies up there. Yeah, so start with these, try and find these two, M84, M86, and go from there. So there's a lot to see in the night sky. Have I left anything out? No? Yeah? Comets. I've got a comet in there. Yeah? It's a shape, just join up dots. Yeah. Yeah. Okay. So a lot to see and do in the night sky. Ah, what? Oh, what's that? Something else. So when you look at the night sky, there's something else out there, isn't there? Right. So our sun is travelling around the galaxy in 1 second, travelling 200 kilometres. And since the birth of our solar system, we've gone round 18 times. That can't be right. It is. When you think of Uranus and Neptune, they're very far from the sun, they're going slowly, yeah, understand that, yeah. But here, it's like a record. The outside of the record is following the inside of the record. It's solid, yeah. So in space, there's something out there, dark matter, which is making our sun travel so fast round the centre of the galaxy. Is it in this room? Dark matter? We've got ordinary matter we can see, dark matter we can't see, but it's in this room. Travelling through our body, it doesn't interact with the atoms in our body, we can't see it. But it's in this room, it's in space, making us go faster than we should be. That's how they found out about dark matter. Galaxies are going too fast. Yeah. One day we'll find out what it is. Right. But we haven't finished our journey yet. We're going to the centre of our galaxy, in Sagittarius, where we find a supermassive black hole, which is doing the stirring, pulling us around. Right, supermassive. Stars have been attracted together, forming a black hole, not just a black hole, a supermassive black hole. And what happens when you get there? Well, if you're looking at an astronaut going into the black hole, that person would seem to be stopped. Time is stopped because light is being pulled back by the gravity of the black hole. It looks like it stopped to an observer. Time seems to have stopped altogether. Yeah. Whereas for the astronaut, they wouldn't notice the clock's ticking away. They get drawn into they get stretched like spaghetti, but they don't know what's going on. But time seems to come to a stop. And I think that's a good time to stop my talk. Right. Thanks for listening. Thanks for coming. Session we had last week, we had someone come all the way from Dartford to get a night sky. And so thank you for coming tonight, all the way from Ramsgate. Right, I've got some things you can take away here. These are upside down, right? Stargazing guides, little, and these are for 7 to 11-year-olds, all about the moon. And these make great glass mats. Yeah, right. Yeah. Okay. Thank you. Okay.